Hi guys, welcome back to Infinite Math Help Squared. As promised, I told you I would follow up with long division from partial quotients, and here we are. Okay, we're going to do a few examples of long divisions because there are different situations. Sometimes the division works out nice, sometimes not so nice. But two things that you could depend on here are that this is going to be a cycle of repetition. If you can get the a few steps noted in your mind or with a rhythm or a beat, then you just repeat those steps over and over again. And then if you can keep everything lined up properly, then following that cycle, everything will just fall into place. I'll show you an example. We're going to start with 492 divided by 6. Now you can see this written a few different ways. You can see this as 492 divided by 6. You can see this as 492 divided by 6. All means the same thing, but this video is focusing on the long division algorithm. Okay, first step. Let's talk about what we could do with the 6. The 6 cannot go into 4 even one time, but it can go into 49. I'm linking a multiplication chart in the video's description for you, because if you'd like, you can use this to help you decide how many 6s can go into 49 without going over. 1, 2, 3, 4, 5, 6, 7, 8. 48 gets it nice and close, so let's go with 8. 6 times 8 is 48. So we're just going to represent that. We were able to get up to 48, but there was still 1 left over to account for. Next, we are going to start the cycle over again. So what you'll notice, most algorithms online, they will tell you your first step is to divide, which we did. We did 6 into 49. Then we subtracted to find out what was our difference. 49 minus the 48 left us with 1. And then that last thing is that we brought down the 2 so we could continue the division. This cycle just keeps repeating and repeating and repeating over and over. And as long as you're keeping everything lined up, you're not going to have a problem. Okay, how many 6s can go into 12? If you go back to your chart, you'll see that it takes 2 of them and you get to 12 with nothing left over, which means we are done. To check your work, you would simply multiply 82 times 6, or if you did it by hand, you can put it into a calculator, but just make sure that you type 492 first and then divide by 6, and you should get the 492 if you're checking by multiplication, and you should get the 82 if you checked with a calculator. Okay, that's that one. Next one is not going to be so pretty. There's my warning. We're going to do 1600 divided by 3. It doesn't look that bad, but it's not going to be as nice as the other one. Okay, 3 does not go into this digit 1. How about 16 though? Yes. 5 3s will get me nice and close to 16. It leaves me with 1 left over. Bring down, and I'm starting my cycle over again. 3 into 10. 3 3s is 9, so there is 1 left over. And bring down and start it all over again. But you should notice here that something is starting to repeat. We're seeing double here, aren't we? Okay, this means that you can stop and simply represent what you have left over as a fraction. This together is a mixed number. 533 1/3 times 3 will yield 1600. Okay. All right. Last one. Also not so pretty. Arguably less pretty than the one that we just did, but necessary to go over because life can be messy, right? So let's do it. We have here 12,809, and we're going to divide by 15. So now you'll notice the multiplication chart I shared is only going up to 10. So let's pretend you weren't allowed to use a calculator. It's a test, it's a quiz, placement test, whatever you want to call it. But long division, can't use a calculator, but we can skip count. Let's see, 15 cannot go into the 1, it cannot go into the 12, but it'll go into the 128. Now let's start to group the 15s and count them. 2 15s is 30, and 30 and 30 is 60. If I double 60, I get to 120, which is very, very close to 128. It only leaves me with 8 left over. So how many is that? If I take the 60 and I double it, that means I have to double what I have right here. I have 1, 2, 3, 4 15s. Double that to make 8. So 8 15s will be 120. Let's see. Where are we at? We're at the part where we bring down now, because we were able to divide, subtract. Now we brought down. Let's start the cycle over again. 15 into 80. Well, 60 is close to 80. That doesn't really look like a 60, does it? Let's do that. Okay. Okay, but if I added another 15 to that 60, I would get 75. 60 and 15 is 75. So 1, 2, 3, 4, 5 15s gets me to 75. I have 5 left over, and I'm bringing down. Cycle repeats over again. Okay, 59. 59 is very close to 60, but I can't use that fourth one or I'll have 60. So that means I'm stuck using only 3 15s, which gives me 45. 30 plus 15 is 45. Okay, what's left over? Well, 45 to 50 is 5, and if I add 9 to that, that's 14 left over. But I'm not done, and I've run out of things here. So I'm going to extend it. I'm going to put my decimal, and I'm going to continue to bring down because I want to know more about this number. Is something going to start to repeat? Is it going to finish? Not sure. 15 into 140. Okay, let's talk about this. Remember we said if we doubled the 60, we get to 120. So 8 of them gave me 120, right? 8 of the 15s gave me 120. So let's see about this. 60 and 60 is 120. If I add another 15 to that, I get to 135. So let's see how many that is. Get rid of part of this. Okay. And another one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of them gets me to 135. There is 5 left over. Let's continue to see if it starts repeating because I'm starting to run out of room too. 15 into 50, 3. 3 15s is 45. I'm starting to notice something. We're left with 5. See, because if I do this again, I'm going to have the 50, and it's going to continue like that. So instead of doing that, I will end it 5 over 15. But 5 over 15 is actually a third, which I could do in another video. I can talk about simplifying fractions for you. So let's do 853.93 and a third. This would be your quotient. 15 times 853.93. Actually, my bad. This is where it started the repetition. So we will put the bar like that. Okay, guys.